You see these pull tabs all over in restaurants and bars all around the state, and I've seen them back in Nebraska where I'm from as well. And these are sort of like scratch-off tickets sold at convenience stores. Basically, they're going to sell these tickets for a certain amount of money. That establishment's going to bring in a total, like in this one, $39.80. And then they're going to pay out a certain amount of winners. Now in this one, you can see the total of the payout is $2,990, which is 75% of the amount brought in. And then they have a profit that's the other 24.9%. So they profit $990, and then they do have to pay for these sets of cards. We're going to look at it from the player's standpoint. The player is paying $1. They might lose. There's a lot of outcomes not shown here, and that's the people that lose. And then there's all these winners. The way to set this up in a statistical way is to set X equal to the profit. And in each of these, I took the payout minus the $1. Next, I put the amount of each one of those tickets and found that total to be 131. And then I subtracted using a sum command. You could also just type the 131 there to find the number of remaining tickets. Next thing I did, I'll go ahead and clear these out, is I did the frequency divided by the total. You could also replace 3980 with the sum of column B. And that would give you that same thing. As soon as you hit return, it will allow you to autofill. You can also click on another cell, click once, and then use your cursor in the bottom right corner, drag to fill down, and then you'll find each one of those individual frequencies divided by the total. And in column D, I'm multiplying X times P of X. And that one didn't autofill for me, so I'll just drag that down. And now you can see the sum is actually given right here. I went off to the side and used the sum command. Another thing I did is I took all of these and they initially had a lot of decimal points. I cut each of those down to 5 decimal points. This one had a lot more, so I reduced it down to basically negative 0.25. Last thing I did is I put a $sign on it. So what I have is the expected value of the random variable X. If you're playing the game, that's going to be the expected profit. So you would expect to profit negative 25 cents every time you play this game on average. Now, if you played it 1,000 times, you might win a bunch of times, but you're going to have a bunch of negative ones. So imagine a total of a whole bunch of negative ones and then a couple of these numbers divided by the number of times you played, and that will tend to approach this expected value or this average profit.